Here's a problem which shows that, as usual, any method might turn out to just lead to more methods, and that might include the same method you just used. This one uses integration by parts twice to get the answer. You're supposed to find the antiderivative of x squared e to the x dx. It's similar to the ones that we did above. It has x squared, and when you take the derivative of x squared, that's 2x, so that's a good choice for you. It simplifies. And then the rest of it would be dv, that's e to the x dx. By the rest of it, I mean everything that x squared is multiplying, the other factor. Then I take the derivative to get du, that's 2x dx, and I take the antiderivative to get v. The antiderivative of e to the x is just itself, e to the x. Then put those back together, so I have u times v, x squared e to the x, minus the integral of v du, so that's the 2x e to the x dx. And I can simplify a little bit by pulling out the 2. X squared e to the x minus 2 times the integral of x e to the x dx. But the integral of x e to the x dx is not one that I know how to do right away. It's another integration by parts. So I put in u equals x, and dv is everything else, e to the x dx. Du is dx, or 1 times dx, and v is e to the x because it's itself again. So it took me 2 steps to simplify that u down, basically, and now it's just a 1. So the on the left, it's equal to u times v, which is x e to the x minus the integral of v du, so e to the x times dx, and I know how to take that integral. That's just minus e to the x. Great, so now I know what that is, and I've plugged it in on the left in the parentheses, x e to the x minus e to the x. So the full answer is the x squared e to the x minus the 2 times x e to the x minus e to the x, and plus c. And we can definitely simplify that a little bit, combine some like terms. So we have x squared e to the x minus 2 e to the x. Oh, really just distribute the 2, and then plus 2 e to the x plus c. Actually, either of those answers would have been just as good. Simple.